Okay, well, I guess it's showtime. Good morning, everybody, or actually, I should say good afternoon, everybody. First thing is I want to make sure that you all can hear me. So can somebody either give me a thumbs up emoji or get off mute and say you can hear me?
I can hear you.
Awesome. Thanks, Justin. Appreciate it. Okay, so here we go. I'm going to go ahead and share Mr. Screen here. And you should see a big ass PowerPoint slide, for lack of a better term. And today is going to be a review of for the test that you're going to have on Thursday. So let's go ahead and talk about that. First thing is you will not have class on Thursday, so don't bother getting onto your on your laptop at 12:30. That won't be necessary. However, I'm still going to administer tomorrow the test on Thursday. The way it's going to work, it's going to be online via Hawks, which is the way it would have been anyways. It's just that you would have be present in class and it would be proctored. Hang on a second. Thanks, Savannah. And the test will open at 8:00 a.m. and it will close at 11:59. However, once you start the test, you have 80 minutes to complete it. The test has 12 questions. I've already created it. It is assigned and it should appear once again on Hawks at 8:00. It is, and these are at my expectations for the test. It's supposed to be closed notes and closed book. You are allowed to have one 8.5 by 11 sheet of paper as a cheat sheet. And I know for a fact that I can't enforce this. So I'm trusting you guys to not to compromise your integrity. I'm trusting you guys to adhere to your values and do what you believe to be the right thing is. And I will cover. Actually, I don't think I'm going to cover 10 problems. I'm going to cover 1, 2, 3, 4, 5, 6. I will cover 7 problems out of the 12 that will serve you well. And basically, the way this works is I took your practice test. I created and I from that I took out 12 problems that comprised the test, and from those 12 problems, I have 7 examples that I can work on, which came from those 12 problems. So knowing these problems will obviously serve you well in the exam. And that is all that I have relative to that. Now, as I mentioned before, you have a cheat sheet. You don't need to see that. Okay, which I have a cheat sheet for you, or that you can use a cheat sheet. One of the things that you might want to consider doing is this. Give me a second to get to to get the Canvas. In Canvas, in your particular class page, which I believe is this one, if you go to modules and scroll down, you'll see test 1 prep and you'll see test 1 formula sheet. It's right there. Okay. This right here could be the start of your cheat sheet. For example, it has all of the formulas that we talked about last Thursday on here. And so you could use this to remind yourself of the formulas. And actually, what you'll notice is that for every single problem, we are always solving for the exact same thing. For example, for this one, we solve for P, this one we solve for F, this one we solve for S, L, I mean, not L, W, and so forth. So you could actually solve these things on your own and write the actual solutions onto this particular formula sheet. For example, here, you could write down P is equal to I divided by RT. Or over here, S is equal to P divided by 4. You could actually have that at the ready for when you take the exam. So this is actually this would be one side of an 8.5 by 11, and on the other side you could put whatever you want. So I want you just to consider that as a possibility for you when you are preparing for the exam. Okay, so the rest of this class, I'm going to basically work problems. problems that I believe will serve you well. And the first problem that I was going to start off with is this one right here. This one is from 2.3b. Okay. And it is 9.6y minus 8.6y plus 1.1 is equal to negative 6.7 plus 7.6. Now, feel free to ask questions. If you want, you can stop. Feel free to go off mute and ask questions if you have a question, or you could also post something in chat. I'm monitoring chat, and I'll do my best to answer them when the questions arise. Okay, so for this one, once again, we want that our goal is to isolate y. You can do it any way you want. Of course, I recommend a certain procedure, and that which is simplifying. In other words, combining like terms and removing grouping symbols. Here we have like terms. We have a like term here, and we have like terms here. Okay. Turns out that 9.6y minus 8.6y, that's just 1 times y, or just simply y, plus 1.1, and that's going to be equal to 6.7, negative 6.7 plus 7.6. That should be 0.9. Negative 6.7 plus 7.6, 0.9. All right, cool. All right, and our job is to isolate y. In other words, you have to get y by itself. Right now, there is exactly one term that is in there. We need to get rid of that sucker, and I can do that by subtracting 1.1 from both sides of the equation. These will cancel. Here I have y is equal to negative 0.2. Okay, any questions about that? Okay, one down, a few more to go. The next one is from 2.3c. And this one involves fractions. Sorry about that. This one is negative 6 over 5u is equal to negative 6. Okay, now let's be back up for 1 second. If you have a problem where it is an integer, say negative 4u is equal to 36, what you want to do to isolate u is to divide by the coefficient. These cancel, and we have that u is equal to negative 9. However, in a fraction, what you want to do is you want to multiply the fraction by its reciprocal. Now notice this fraction is negative 6/5. So to make this equal to make the coefficient 1, I need to multiply by the reciprocal of negative 6/5, which is going to be negative 5/6. Basically just flips the equation upside down. Okay. If I do that, if I'm multiplying this side by negative 5/6, I have to do the exact same thing over here. Don't forget the negative. That would be bad. All right. So if I do that, this will cancel. This will have a coefficient of 1. I'll have 30 over 30 u. That's going to be equal to negative 6 times negative 5/6. All right. This is going to be equal to 1. And then for the next part, if you're not sure, we can just do negative 6 times negative 5 divided by 6, and that will hopefully give you 5. And that would be our answer. So in scenarios like this, divide by the coefficient. If you have fractions, do the reciprocal, which is basically take a fraction, including the associated sign, and flip it and do that to both sides. Okay? Any questions so far?
How did you get 5?
Okay, so I have this is basically negative 6 times negative 5 divided by 6. Okay, so what you could do in your calculator is negative 6 times negative 5 divided by 6, and that will give you 5. Okay. The other thing that you could do is, okay, the other thing that you could do is this. -6 times -5 divided by 6. Well, this is division, right? So these cancel. I have a -5. That is 5. But knocking it out in the calculator just like this is a perfectly good way to figure that out. Okay? All right. Next is a 2.4 problem. I actually want you guys to know that yesterday was a really big day for me because yesterday was the first day since Friday I was allowed to take a shower. I was getting so nasty I could smell myself. My wife is my wife is very happy about that. Okay, so this is the problem from 2.4.
Why couldn't you shower?
Say what?
Why couldn't you shower?
To protect my wound.
Okay.
Or more importantly, I couldn't take a shower because my surgeon told me not to.
Oh wow.
I'm trying to be a good little patient. All right, so in this sucker, we want to get once again we want to solve for u. And here, remember we want to use addition to move terms. And we want to use multiplication to reduce. Okay, I can spell. Reduce coefficients to 1. Okay. Once again, there's nothing to simplify here, so we basically need to reduce terms. So notice the first thing we want to do is get this so that we only have the u term, the term with the variable in it, on one side and everything else on the other side. So we need to move this 5. Okay, we have a +5. The opposite of +5 is -5. So we want to subtract 5 here, subtract 5 here. Adding vertically, these cancel. Over here we have -20. And over here we have -7u. Okay, now we can multiply specifically, just get rid of that coefficient. Since the coefficient is -7, we divide by -7. Okay, these will cancel. We will have that u is equal to -20 divided by -7. Now the two negatives cancel each other out. You can almost look at this as, -1 times 20 divided by -1 times 7. These cancel. We have 20 over 7. Okay. Now let's just so here we have a fraction. We want to make sure it's in reduced form. So what we can do is, well, we can either we can evaluate this in our calculator, or we can evaluate this in our calculator. And actually, I have the wrong calculator up. I want to use my other calculator. I actually just purchased it. Well, actually, I didn't purchase it yet. I just downloaded the free trial. It's here somewhere. TI Tools. There it is.
While you're waiting, I have a question about attendance.
Yes, ma'am.
So, since we're present on this call, is that going to count for our attendance?
I am not taking attendance.
Okay.
So, I'm glad you're here. I'm going to simply say that if you choose to miss class, you miss it at your own peril. But for the 2 weeks that I am out of commission, I would like you to come. I love seeing these circles with the letters EF on it or the letter J on it. But I am not going to record attendance until I'm back until I'm back in class.
Okay.
All right, so let's take a look. So we have here that u is equal to -20 over 7. We want to, and so we actually have a fraction. We want to make sure that this is correct, or that we want to, but we had to express this in its reduced form. So here's what we can do, and this is a TI-30. This is one of the less expensive calculators. We can type in -20 divided by -7. Okay, we get that. Now you see this button right here. This is the FD thing I've always been talking about. Second FD, hit enter. That's the reduced fraction. That will be your answer for the problem. Okay, that's just like doing what I've been doing. Well, you've seen it before. I'm not going to show it to you now. Doing what I've been doing on my TI-84. And TI-84, you know, if you haven't bought it, $100. TI-30, I think it's 20. So at least
Wait,
if
what's
you
the
can't.
reduce?
I'm sorry.
Is it the 20 over 7? Is that still the answer?
That's the answer. Yes, right there.
Okay. And I had a question about that about the previous problem.
The previous, this one right here.
Yeah. So on the homework, I had a question that wasn't set up with a like it didn't start off with a fraction, right? But I still had to multiply both sides. How would I know how to do that like off the rip if the problem's not set up with that?
If you had a problem that was not set up like a fraction.
Yeah, it was set up like as a whole number, but I had to
Okay.
use that multiplication.
So if you had a problem like 6x is equal to 72, like that.
Yeah.
Okay.
No, I had a third number. It was like 6x plus 6 equals 3x plus 6.
Oh, actually, we're getting next to that. we're actually getting to that problem. 3x plus 6. Okay.
Yeah.
So that actually is
my
a 2.
bad. It was 4x, not 3x.
I'm sorry.
It was 4x, not 3x.
Okay, cool. I can fix that. 4x. Come on. Maybe I can't fix it. Now okay, 4x. X is going to be equal to 0 for that one. So this is basically a 2.5 problem. Okay, well, basically for this one, you want to get all the terms with an X on it to one side, and then all the other terms to the other side. Can I actually change this just a little bit?
Yeah, go ahead.
Okay, I'm going to change this to -6. Because if I don't, I'm going to have 2x equals 0, and then x is going to be equal to 0. So, okay. So for this particular problem, this is one of the problems where you want to move, you want to use addition to move all the x terms to one side and then all the constants to the other, but you want to do it in such a way that your coefficient is positive. Makes life easier for you. And I'm here to make life easier for you, believe it or not. Okay, so what you might want to do is subtract the smaller, the term with the smaller coefficient from both sides of the equation. For example, here, the term with the smallest coefficient is 4x. So I'm going to subtract 4x here. I'm going to subtract 4x here. Okay. If I do that, these cancel. All I have over here is 6. Over here, I have 6x minus 4x, which is 2x. So I've got to bring down the -6, and I have that. Okay, so that's the first thing that you want to do. You actually want to get, your strategy is you want to make sure when you move your x to the one side, you have positive coefficients. Now we want to do addition so that this term is all by itself. Okay, since it's being subtracted by 6, the opposite of that is adding 6. Ooh, that hurt. Adding 6. Got to do this on the other side as well. All right. These will cancel, and we will have 2x is equal to 6. And then finally, we have a coefficient of 2. Since it's an integer, just go ahead and divide by that coefficient, both sides. These cancel, and we will have x is equal to 3. Okay, and the only reason why I wanted to change this was so that we had a more interesting answer than 0.
Why is it?
Wouldn't that be 12?
6 plus 6? I mean, 6.
Oh, did I do that wrong? Oh, you're right. I screwed up. You were right. I apologize. I messed up. Let me fix that. I have no idea. Okay. So what's 6 plus 6?
12.
It's 12. You sure?
Yes,
Okay, I'll take your word for it. Now we divide by 2.
My only concern is when I did that problem, when I obviously I got it wrong, so I went to back to learn. It had me add 3x to both sides again, so I'd be able to add like terms and then multiply All right, multiply the thing by the fraction.
Okay, so basically what you had basically 3x is equal to something, right?
Yeah.
Like, okay, like I don't know what, 12, and then they said multiply by the fraction, which would be 1/3. That was their suggestion on the approach.
Yes, sir.
Okay, perfectly good way to do it. My feeling is that, and that's one of the problems in this particular subject, is there's lots of ways to solve these, and their approach is simply different than mine. My approach is, if you have an equation like a statement like this, where x is being multiplied by an integer or a decimal coefficient, just divide by that coefficient. That's not the coefficient, sorry, my bad. Just divide by that coefficient. So if you have that, or if you have 3.3x is equal to 12, divide by 3.3. I mean, that we're both saying the same thing, just in a different way. So if you have an integer coefficient or a decimal coefficient, divide by the coefficient. Okay, and you'll get your and these will cancel. Now, having said that, if you have a fraction, then what I recommend is that you multiply by the reciprocal of the fraction. Okay, because this times its reciprocal is equal to 1, which will just give you x, and then we can figure out what this happens to be. That actually would be 24/5, which you can't reduce anyways. So that is my recommended approach. If you are, actually, if you are, there we go. If it's a decimal or an integer, just divide by whatever that number is. If it is a fraction, flip it and then multiply through. Hopefully that's not too confusing. I mean, hopefully it's not too confusing. I know that the way they do it is a little differently than the way that I teach it, which I know can be confusing. But does that work for you?
Yes, sir.
Okay. I would recommend just work in a couple of times. If you still have an issue, shoot me an email, and we can do this, this online thing again. Okay.
Yes, sir.
All right. I have another 2.5 problem, and that is not the eraser emoji. There he is. Okay, I want to use this. And this one involves dealing with grouping symbols. So here we have 3 times 3y plus 2 is equal to 3y plus, 18. All right. So this is also from section 2.5. Those who have y's on both sides. Now here we need to simplify. Simplify. Now we have grouping symbols that we need to get rid of, and then we'll probably also have to combine like terms. The first thing that we need to do is to get rid of the grouping symbols, and we use that using the distributive property. And that basically says that A times the quantity B plus C, not A again, C, is going to be equal to A times B. In other words, A gets multiplied by every single term inside the grouping symbol. Okay, so here we have a 3 times the quantity 3y plus 2. That's going to be equal to 3 times 3y, which is 9y, plus 3 times 2, which is 6. And then over here, we just simply have 3y plus 18. Fortunately, we have no like terms to combine, so we're good to go. So now we want to add, and once again, in such a way that our coefficient is going to be positive. And we can do that by subtracting out the term with this, or the term with the really smallest coefficient. That would be this one right here. All right, so minus 3y, minus 3y. These cancel. Over here, 9y minus 3y, 6y plus 6 is equal to 18. And now we want to get this term by itself, and we can do that. I don't want to do that by subtracting 6 from both sides. Okay, so you're going to be a pain in the butt, huh? There we go. Minus 6, minus 6. And that will give me, well, these will cancel. Okay, over here we'll have 18 minus 6, that is 12. 6y is equal to 12. So we've done all the addition that we need to do. We've moved all the terms. So now we want to multiply to get rid of the coefficient. Okay, since my coefficient is 6, I want to divide by 6, which is just the same as multiplying by 1/6. Divide by 6 here. These cancel. And then I will have that y is equal to 2. Okay, any questions about that? All right. I have 3 more problems that I want to go over. And I'm going to do those in Hawks. Remember where the hell I put it. Should be here. Okay. So here's Hawks. I need to get, so I need to bring you over. I need to bring you. I didn't want to do that. What, let's do it like this. You go here. You go here, and you go there. There we go. Okay, that's what I'm looking for. So if I want to make you a little bigger, and you a little bigger, and we want to go to section 3.1. So I need to view course, put all my lessons, because I think 3.1 is one I've already done. Yep, there it is. And I want to go to, not that one, this one. Okay, so here, let me see if we can make this just a little bit bigger. Okay, so here, Larry is planning a vacation. It turns out the travel agent says that the average high temperature at this resort is 20 degrees Celsius, so it's going to be nice and warm. What is the equivalent Fahrenheit temperature? Okay, so the first thing that you need to do, remember, is to choose the correct formula. Now, if you use my cheat sheet the way I recommended you do, here it is. You will notice that we're talking about, wrong one. We're talking about temperature, Celsius and Fahrenheit. That should help you to deduce that this is the equation that we're talking about. This one right here, okay? Which of course is this one right here. Okay, so you want, so that is going to be our correct formula. Now in the second part, we want to express this. I need to get there first. We want to express this in terms of the unknown variable. The unknown variable is Fahrenheit, which is F. Okay, and yeah, Fahrenheit, which is F. So if you forgot what you pressed, what you selected before, well, at least in your test, you can go back and look. You can actually move all throughout the test. Here, you can just write this down. Okay, so here we have C. C is equal to 5/9 F minus 32. And remember, we want to solve for F. You want to get F by itself. Now, this is one of those problems where the procedure that I recommended isn't probably the easiest way to go. Remember, my procedure would be to first get rid of this, would be the get rid of the grouping symbols by multiplying 5 nines by F and then by 32 and go from there. In this case, it would be easier to multiply both sides of the equation by the reciprocal of 5 nines. 9/5. Okay, the reason why is because then these will cancel. The 9s will cancel, the 5s will cancel. The coefficient is 1. If the coefficient is 1, we no longer need grouping symbols. So we'll just simply have F minus 32. Okay, and over here, 9/5 C. And then finally, we can complete it. We can finish this up by multiplying both sides, or adding 32 to both sides. Okay, these will cancel. And we have that 9 over 5c is plus 32, almost forgot that, is equal to f. All right. Now, so this, if you ever have this problem, this is what you're going to be solving for. So what you could very well do, or you could also write this as f is equal to 9/5 c plus 32. And there's really no reason whatsoever why you could not take this sheet, print it out, and write this right there so that you are ready for parts 1 and part 2. Now, as far as this is concerned, I'm going to write it like this. So I'm going to have, I'm going to use my keypad, get it out of the way, fraction, 9, down cursor, 5, right cursor, c plus 32 equals f. And there you go. Moving on. Now this is where we actually put in our numbers, and they tell us that c is equal to 32. No, c is equal to 20. My bad. Okay, so we're going to substitute 20 in for c. That means that f is equal to 9/5 times 20 plus 32. So actually 20 divided by 5 is 4. 9 times 4 is 36. 36 plus 32 is going to be 68. Okay, that's one way you can do it. On your calculator, you can do it as follows. 9 divided by 5 times 20 plus 32, 68 degrees. And that will be your answer. Okay, so over here, type in 68. And you are good to go. Okay, any questions about that?
No.
All right, well, okay, Justin's got it going. Anybody else? Okay, moving on. So that is the one token 3.1 problem that I wanted to do. I think the only other one I wanted to mention is, I'm not going to go to it, but just remember, like, if you're dealing with a circumference of a circle problem, then we have c is equal to 2 pi r. You're going to want to solve for r. R is going to be equal to c divided by 2 pi. When you put that in, that's where you find the pi. Okay, just want to throw that out there. All right, then I have 2 more problems I want to do. They are both relative to section 3.4. So let me get over there. Here it is, 3.4. This is Monday's class, not you. Yours is not. Yours is already due. They lost an extra day because of my surgery. Okay, so let me get this going because I wanted to do this using their interface because their interface is somewhat unique. I just want to make sure I find a decent problem. That one's boring. Yeah, let's do this one. Okay, so this one, we're looking at the inequality, and we want the answer. Actually, hang on a second. Let me look at the other one. Okay, well, actually, bear with me 1 second. I got to start over again. Not that one. Okay, this one. Here we have 2x plus 5 is equal to -8. Whoop, didn't want to do that. Stop that. -8. Okay, so not equals to, strictly less than. Okay, so remember, when we're solving for an inequality, we're actually looking for the number or numbers that divides the real line into intervals. And the other thing about about inequalities is that if you have to divide by a negative value, the sign actually changes, and we'll do an example that shows that. But the goal is still the same. We want to isolate x. We want to get x by itself, and we will still want to use addition to move terms, multiplication to get rid of coefficients. So here we have an extra term plus 5. To move that term, we need to subtract 5 from both sides. So subtract 5 here, subtract 5 here. Okay, these will cancel. Here I have 2x. That is strictly less than negative 13. Okay, and then finally we need to divide by 2. So divide by 2, because that's our coefficient, divide by 2. And we will have that x is strictly less than negative 13 over 2. Now, we want to make sure that that is reduced. A lot of you can probably look at that and know that it is. If you're not sure, just do negative 13 divided by 2, hit enter, hit FD, and it will tell you. So negative 13 divided by 2 is our answer here. So we are going to put in x is strictly less than negative, not that, fraction, negative 13 divided by 2. Okay, now one of the things I wanted to point out is that on your test, you will never, ever have to press these buttons, okay? Every single question is going to give you an answer here. If you decide that this is your answer, you are making the wrong answer. Just wanted to throw that out there. Okay, let me see if I can. Okay, let's go ahead and do this problem as well, because this one has a negative 2 in it. So here we have, oh, wait a second, there was another problem. Okay, let's go ahead and do this problem anyways. So here we have negative 2x minus 2 is less than or equal to 4. Okay, once again, when I get this by itself, so plus 2, plus 2. These cancel. We will have negative 2x is less than or equal to 6. Okay, now to get rid of this coefficient, I need to divide by that coefficient. Divide by negative 2. Divide by negative 2 here. Now, since I'm dividing by a negative number, this direction of this inequality is going to change. We're going to go in this direction now, and these will cancel. I have x is greater than or equal to negative 3. Now, how can we be sure that this is correct? Well, what we can do is we can pick any number in this interval, any number that's greater than 3, to see if it satisfies the inequality. For example, what number is greater than negative 3? How about 0? X equals to 0 is within that interval. And if x is equal to 0, we're going to have negative 2 times 0 minus 2 is strictly or less than or equal to 4, which basically reduces to negative 2 being less than or equal to 4, which is a true statement. So we know that we're correct. So this answer is going to be x is greater than or equal to negative 3. The way you do that, hit your keypad. Type in x. Use this for your non-strict inequality. Wait, first, let me get that x in there. Non-strict inequality, negative 3. Boom, there you go. Okay, now, shoot.
So why is it that it's greater or equal to? Because we all know it's clearly not equal to negative 3.
Because how the problem is stated, it was stated originally with a non-strict inequality.
Okay.
That always stays.
Okay, so if it starts off with that, we have to finish with that.
Yes, if it starts off strict, it stays strict. If it starts off non-strict, it stays non-strict.
It'll never change.
Never. The only thing will change is direct. The only thing that will change is to direction. Good question. You probably just saved people a whole lot of grief. Okay, here's the next part. Next part is we actually need to graph this one. Okay, now I always recommend that when you're doing this, you probably want to write this in interval notation. And here's okay, and so let's go ahead and do that. Notice that the lowest value is going to be negative 3. Okay, because we're looking at all numbers larger than that. So the lowest number is going to be negative 3. The symbol associated with that number is a non-strict inequality, so that implies a bracket. The highest number is going to be infinity. And whenever you have an infinity, it's always going to be a parenthesis. So the reason why you want to do this is because these symbols will determine which one of these you grab. Since I have a bracket in the left, parenthesis on the right, this is what I want. Okay, so click on that, and here we go. Now I want to move this to negative 3. I can do that without
So
hurting myself.
Can you repeat that one more time? I'm not sure how you got that.
Okay, to get this into interval notation, what you want to do is you want to basically start off with the smallest number. Now, since we're dealing with x greater than or equal to -3, -3 is going to be the smallest number. Okay, so our smallest number is going to be -3. This symbol is associated with the -3, and it is associated with the -3. So since it's a non-strict inequality, that means this symbol is going to be a bracket. Whenever you see this, it's a bracket. This is a bracket. A strict inequality are parentheses. Okay, so since we have a non-strict inequality, we have bracket, comma. We're going to go all the way up to infinity. And on the real line, you can never, ever, ever reach infinity. So infinity will never, ever, ever have a bracket. So
why is it that we use infinity?
What's that?
Why is it that we use infinity?
Yeah, remember, because this is x greater than or equal to -3. So it's every single number higher than -3 all the way up to infinity.
Okay.
Okay. If it was x less than or equal to -3, well, then that would be all the numbers below -3 all the way down to infinity. So in that particular case, your smallest number would be -infinity. I actually jumped the gun there. Since it is an infinity, it would have a bracket, and then your largest number here would actually be -3, and that would have a bracket because of the non-strict inequality. Okay? But the advantage of doing this here, because this right here is our problem, right? The advantage of doing this here is because these symbols tells you which one of these you want to pick. Since I have a bracket on the left, a parenthesis on the right, I want that bad boy right there. Okay? Once they're up, then I need to move this to wherever -3 is, which is right there. And then for infinity, just move it to the arrow. Okay? So that's how you do that. But I would recommend that you write it in interval notation, because then you can actually map these symbols to these buttons here. And we're going to do one more just to bring it home. Okay, any questions so far? Okay, let's just make sure I didn't screw this up.
No, sir.
Boom, there you go. Okay, I have one more that I want to do. It's a compound inequality. I have to remember to hit skip and not select the answer. Yeah, let's do that one. Okay, so here we have -10 is strictly less than -2z plus 4, which is strictly less than -2. Now, in this one, we want to isolate z in the middle. This is kind of like monkey in the middle algebra style. And now what we want, and we're still going to use addition to move terms. We're still going to use multiplication to get rid of the coefficient. However, whatever we do on one side of the inequality, we have to do on the other two sides of the inequality, because now we have three sides. Okay, so our first thing is to get this term by itself, and we can do that by subtracting by subtracting out this particular term. So I want to subtract 4 here. If I'm subtracting 4 here, I have to subtract 4 on the other two sides. If I do these cancel, over here I have -14. That is strictly less than -2z, which is strictly less than -6. Okay, now what I want to now to get rid of the coefficient, I just divide by that coefficient. So divided by -2. Once again, if I'm dividing by -2 here, I need to divide by -2 here and -2 here as well. Now, since I'm dividing by a negative number, the direction of this inequality is going to change. It's going to change into this. Well, I didn't want to do that. This direction. Okay. Over here, these cancel. I have z. That's what I'm looking for. Here, I have negative 14 divided by negative 2. That's going to be positive 7. And over here, I have negative 6 divided by negative 2, which is equal to 3. That is your answer. Now, note it. Well, actually, that's not your answer, because look, they want your answer in interval notation. This is algebraic notation. Okay, now remember, in interval notation, we always start with the smallest number. However, in this particular case, and usually the smallest number is here. Well, not this time. This time, the smallest number is here. It happens to be 3. Okay, so we start off with 3. We always start with the smallest number. All right, the symbol next to the 3 is a strict inequality. That is parenthesis. And then the next number is 7. Symbol there is a strict inequality. There you go. That is your answer in interval notation. Now, the way you can put that in, putting that in is relatively straightforward. You don't need to use the keypad if you don't want to. So that should be 3, 7. What? Oh, I know what's going on here. Oh, so what happens is, if once you put in your parenthesis, it puts the other one in for you. So 3, 7, and it doesn't like me to do it again. So that's just weird. Okay, submit, and it's correct. Now we need to plot it. Okay, but you really can't. In terms of the test, you don't have this. You don't have this previous part answered, but you can move around through the test. As far as this is concerned, notice that we have brackets, parentheses on both sides. That implies this, and then we just move this to 3. Move this to 7. There we go. And that's it. Okay. Any questions so far? All right. There is one more thing I wanted to talk. There's one more thing I wanted to talk to you guys about before I let you all go, and that is just some mechanics relative to the test. So let me get to the practice test. So in the practice test, you don't really have previous test answers. So for example, for this one, you can click the correct formula, go to the next part, and if you forgot what the formula is, you're not going to see it here. You can just have to go back and remind yourself what it was. So here it was S is equal to P divided by 4. And then it doesn't give you any feedback. And once again, if you forgot what it was, you can just basically move throughout the thing to actually figure out what it was. So here it's going to be 10 divided by 4 or 2.5. Hopefully that's correct. So that's pretty much how you would do this. You kind of just walk through it. You can walk through the entire thing, or you can actually hit question numbers and go to the specific question that you want. That's how you navigate. But you won't get any feedback until you submit the test. Once you submitted the test, then it'll tell you all the ones you got right, and then all the ones you chose not to do. That's kind of what I have here. So are there any questions? Okay, once again, you can take the test anytime you want on Thursday between 8 and just before midnight. So you don't have to come to class. You can sleep in, recover from morning practice, and take it when you're ready. If you have any questions, please feel free to contact me. As far as the rest of the class is concerned, I'm going to stay online in case anybody has any questions. I will remain online until the end of class, so 1:50. And you guys are done. You guys are good for the rest of the day as far as I'm concerned.
All right,
and then you too. And I will hopefully see you guys virtually again next Tuesday.
Bye. Thank you. Have a good one.
Yes, sir. You too.